In this video, we are going to talk about moles. Okay. In chemistry, a mole is not, a little furry animal. That's biology. In chemistry, a mole is an amount of something. Okay. So when we're looking at molecules and atoms, we use moles. It's used to count items that are very, very small. All right. It allows us to take something that's submicroscopic and convert it into an amount that we can actually see. All right, so we can't see atoms and molecules, but by putting it into moles, it's an amount that we can actually see and work with in the lab. All right, so what amount though? That's the big question here. In chemistry, the amount that represents a mole is 6.02 times 10 to the 23rd. It's known as Avogadro's number. So it's a very big number. It's not like a dozen. A dozen is 12 or, a ream of paper is 500. It's a much larger amount here. But what is that of? Is it 6.02 times 10 to the 23rd donuts? Is it 6.02 times 10 to the 23rd piece of paper? No, it's what we call representative particles. It's the smallest piece of the chemical substance you're looking at. So if we're talking about a mole of an element, the smallest piece of an element is an atom. So if you had 1 mole of any element, you'd have 6.02 times 10 to the 23rd atoms of that element. Well, what if you're looking at an ionic compound? The smallest piece of an ionic compound would be a formula unit. So you would have 6.02 times 10 to the 23rd formula units if you had 1 mole of an ionic compound. If you had a molecular compound or a covalent compound, the smallest piece of that is a molecule. So if you had 1 mole of a particular covalent compound like water, you would have 6.02 times 10 to the 23rd molecules of water in 1 mole. So it changes, all right? The representative particles here depend on what type of substance you're looking at. But we do know that there's 1 mole for every 6.02 times 10 to the 23rd kind of representative particles here. This picture is just trying to help you understand the mole a little bit better. So if you had 1 carbon atom, all right, it would just be 1 carbon atom. You wouldn't be able to see it. It'd be so small. Well, what if you had a dozen carbon atoms? Okay, well, that would be 12 carbon atoms, all right, because that's what a dozen means, but you still wouldn't be able to see it. We wouldn't be able to work with it. So by having a mole of carbon atoms, we know that 1 mole of carbon would be 6.02 times 10 to the 23rd atoms of carbon. And we also know that that would be equal to about 12 grams of carbon if you remember the note video from before. Okay, so you have to think about this in terms of a mole being a very large amount, but it's an amount that we can actually use and work with. So if you had, say, CO2, 1 CO2 molecule, all right, you wouldn't see it. If you had a dozen of them, you'd have 12. If you had a mole of CO2 molecules, you'd have 6.02 times 10 to the 23rd molecules of CO2. And that would be about 44 grams, or the molar mass of CO2. So now there are some new conversions here that we can add to our list of conversions that we need to know. We know that there's 1 mole for every 6.02 times 10 to the 23rd, but it depends on what substance you're dealing with here. So you might have 1 mole equals 6.02 times 10 to the 23rd atoms if you're looking at an element. All right, you might have 1 mole equals 6.02 times 10 to the 23rd molecules if you're looking at a covalent compound. Or you might have 1 mole equals 6.02 times 10 to the 23rd formula units, okay, if you're looking at an ionic compound. The key is it's still basically one conversion. It's just that the 6.02 times 10 to the 23rd units can change based on the substance you're looking at. But because these are conversions, we can use this now in dimensional analysis problems. So dimensional analysis here is back, and we'll have to do math, and we have to worry about sig figs again. Let's look at our first sample problem here, and I have this one completely set up and solved for you so you can see one full example. So if you look at this problem, it says that you have a sample of magnesium that has 1.25 times 10 to the 23rd atoms of magnesium, and we want to know how many moles of magnesium are contained in this sample. So we're doing a conversion here. We're trying to go from atoms of magnesium to moles of magnesium. Okay, so if you remember back to when we did dimensional analysis problems, you always start the problem with what you're given. So we were given 1.25 times 10 to the 23rd atoms. So that's what we're going to start with. You immediately put your multiplication symbol, you put your conversion line. And then remember, without even thinking, whatever units are on top, you immediately write them on the bottom. So atoms were on top, you immediately write atoms on the bottom. Because remember, the only way these units are going to cancel is if one's on top and one's on the bottom here. So that'll get rid of our atoms when we're doing the problem, and then we'll be in our new unit. Okay, so you immediately know that atoms of magnesium go on the bottom. So you're trying to get to moles. So you say, okay, do I know conversion from atoms directly to moles? And the answer is yes. We know for every 1 mole, there's 6.02 times 10 to the 23rd atoms. Okay, so your atoms are already on the bottom, so the 1 mole goes on top. And then notice here that your units will cancel. Atoms on top, atoms on bottom, so they cancel. You're now in moles. All right, so now you just need to do the math correctly here. All right, remember, you multiply across the top, get a number, multiply across the bottom, get a number, then divide the two numbers. Because you're dividing two numbers here that are exponents, you want to make sure that you put them in parentheses or you're not going to get the right answer here on your calculator. So I would definitely make sure you can plug this in your calculator and get it correct. But when you do this, okay, you definitely need to make sure that you're watching your sig figs. So we're just multiplying and dividing here. So you go back to the problem and you see how many sig figs you started with. So in this number here, we only have 3 sig figs. So our answer needs 3 sig figs. Okay, and then you do need to include your units. Your atoms canceled, so the units you're ending with here are moles. And you can use MOL as an abbreviation for mole. I know it's, one letter short, but that's the abbreviation they use for mole. You don't need to include the substance here. Okay, you could just have this as your answer. All right, the substance is not necessarily important here because we don't have like multiple answers for this problem. There's only one answer. So you can just give that answer in correct sig figs with the unit. So this is a pretty basic example of how you convert from atoms to moles using the conversions we just talked about. Let's try another example here. In this one, we want to know how many atoms are there in 1.23 moles of xenon. The beautiful part about these problems are that they're pretty much all the same. They use the same kind of setup, it's just the numbers change. So we're going to do a dimensional analysis problem, so you always start with what you're given. So we have 1.23 moles is what we're starting with here. You put your multiplication symbol, you put your conversion line. Without even thinking, whatever unit's on top, moles, you immediately write it on the bottom, okay? According to the problem, we're trying to get to atoms here. So we ask ourselves, do we know a conversion from moles to atoms? And the answer is yes. We know there's 1 mole for every 6.02 times 1023 atoms. If you're wondering why I'm saying it like that, make sure you watch the Mold Day Baby video. You'll never forget that 6.02 number. Okay, so we have moles on top, moles on bottom, so they cancel. All right, so we're in atoms, which is what we want. So now we just need to do the math. Multiply across the top, 1.23 times 6.02 times 10 to the 23rd. There's nothing to divide by. Okay, get your answer, but you need to watch your sig figs here. Okay, pay attention to your sig figs. We started with 3, so we need 3 sig figs in our answer. All right, so when you do this, hopefully when you plug it in, you get 7.40 times 10 to the 23rd, and your units are atoms. Okay, so we want 3 sig figs. We need our units there. All right, so make sure you can actually get this when you put it in the calculator. If you're feeling good with these problems, maybe you could try this example, pause the video, try it on your own and see how you did. But in this example, we want to know how many moles of magnesium chloride are 7.78 times 10 to the 24th formula units of magnesium chloride. And when people see formula units, they always get scared. They're like, I don't know what that is. Don't worry about it. You already know that there's 1 mole for every 6.02 times 10 to the 23rd, either atoms, molecules, or formula units here. But the key is these problems are all the same. So you're going to start this problem the exact way you started every other problem. You write down what you're given. So you have 7.78 times 10 to the 24th. All right, in this case, it's formula units. You can abbreviate them F period units. Okay, you can't abbreviate them FU. All right, so just be careful with that. So we write what we're given, we put our multiplication symbol, we put our conversion line. All right, without even thinking. Whatever unit's on top, you immediately write it on the bottom. So we got F period units, formula units here on the bottom. All right, so we're trying to get to moles. So we ask ourselves, do we know a conversion from formula units directly to moles? And the answer is yes. We know that there's 6.02 times 10 to the 23rd formula units for every 1 mole. Okay, Formula units on top, formula units on the bottom. All right, they cancel. So now you're in moles. All right, that's what we want. So we're done here. Just be careful with your math. You are dividing exponents here. So you want to make sure that you're using your parentheses or you won't get the correct answer here. All right, so you got to watch your sig figs. We started with 3 sig figs, so your answer needs to have 3 sig figs. All right, so hopefully when you plug and chug this, you get 12.9 moles. All right, so be careful here. Watch your sig figs, watch your units in your answer, circle your final answer, and make sure you can actually get this in the calculator. For this example, I'm going to encourage you to try this on your own. Okay, so right about now, you want to pause the video, and then when you resume, you should be able to see the fully solved problem. Okay, so pause the video, try it. Okay, so let's see how you did here. Hopefully you got this answer. All right, just a couple things to point out for your sig figs. The answer should be 2.74. Your calculator gave you 2.745. All right, but the rule when you have a 5 is go for even. So the 4 is even, so you stay at 2.74. And obviously it's still times 10 to the 24th. All right, for molecules, you cannot abbreviate them moles because obviously they're different. So yes, you got to get used to just writing out the word molecules. All right, so these were some pretty simple practice examples here of using the new conversions. So far, we've looked at a conversion involving moles to atoms, molecules, or formula units, but sometimes we need to be in grams and not moles or one of those units. If we were in lab, we want to be able to use grams. So we already know a conversion here that we can use. We know from our molar mass stuff that 1 mole equals the number of grams from the periodic table for an element, or 1 mole equals the number of grams for the molar mass. All right, so now you can use this conversion in your dimensional analysis problems. If you need to be in grams, we now know that 1 mole equals a certain number of grams for the element or for the compound. So now we can start to do problems including this conversion. We are going to jump right in and do an example here. So notice I solved the whole thing for you. I'll walk you through it so you can see it all, and then we'll go in and actually do some problems together. So the first problem says, how many grams are there in 9.87 moles of H2O? All right, so it's dimensional analysis. Start with what you're given. All right, 9.87 moles. Okay, you put your multiplication symbol, you put your conversion line. Without even thinking, whatever units you have on top, you immediately write on the bottom. Okay, so we have moles on the bottom, and then we would ask ourselves, we're trying to get to grams. Do we know a conversion from moles to grams? And the answer is yes. All right, remember here, we know for every 1 mole of water, all right, there's going to be a certain number of grams, okay, of water. That is going to be our molar mass stuff here. So we have to do a molar mass because this is water, because this is a compound. You have to actually do your molar mass, and you would have to show your work here in the problem. So you know there's 2 hydrogen with 1 gram each, 1 oxygen, 16 grams. When you total it up, you get 18 grams per mole. Okay, that is molar mass. There's 18 grams for every 1 mole. So now you can use that and plug that into your problem. So we know that for every 1 mole of water, there's 18 grams of water. So if you have a compound here and you need to use grams, you might have to find a molar mass in one of these problems. All right, your moles would cancel. Okay, moles on top, moles on bottom, they cancel. So your units would be grams. You just need to plug it, chug it, solve for the number of grams, and watch your sig figs. So when we do this, it does come out to be 178 grams with correct sig figs and units. Okay, so this is just another conversion we can use in these problems. Let's try another example here. All right, so this says how many moles are there in 22 grams of copper? So we start all the problems the same. We write down what we're given. We have 22 grams here. All right, multiplication symbol, conversion line. Without even thinking, whatever unit's on top, you immediately write it on the bottom. So we got grams on the bottom. All right, we're trying to get to moles. So we ask ourselves, do we know a conversion from grams directly to moles? And the answer is yes. We know for every 1 mole, there's a certain number of grams here with the molar mass. So we know that for every 1 mole, there's a certain number of grams. Well, in this case, this is just the element copper. In the previous example, it was water, so you actually had to do a molar mass calculation. But for this one, since it's just copper, you look it up on the periodic table and you round, and you see that there's 64 grams of copper for every 1 mole. So you have grams on top, grams on the bottom. All right, this was much easier. You didn't have to do an actual molar mass calculation because it was just an element. Now you're in moles, okay? So now you just need to do the math and watch your sig figs. So when you solve this one, you should get 0.34 moles, 2 sig figs, and your units, okay? So make sure you're showing all your work. Make sure you're circling your final answer here. If you're feeling good with this, go ahead and try this on your own. All right, pause and come back and see how you did. But if you want to walk through with me, let's go through it. So for this one, we want to know how many moles is 5.69 grams of NaOH, sodium hydroxide. So you start the problems the exact same way. You start with what you're given, 5.69 grams. Multiplication symbol, conversion line. Without even thinking, whatever unit's on top, you immediately write on the bottom, grams. So I'm trying to get to moles. Okay, so I ask myself, do I know a conversion from grams directly to moles? And it's yes. We know there's always 1 mole for a certain number of grams with the molar mass. So there's always 1 mole for a certain number of grams. Now in this example, it's NaOH. Okay, so you can't just look it up on the periodic table. It's a compound. You're going to have to do the actual molar mass calculation here. So you have to show this in your problem. So you have 1 Na times 23 is going to be 23. All right, you have 1O times 16 is 16. And you have 1H times 1 is 1. All right, so when we total this all up, we get 40 grams per mole. So there's 40 grams of NaOH for every 1 mole. So now we can write that in here. There's 40 grams for every 1 mole. Grams on top, grams on bottom, they cancel. Now you're in moles, which is what we want. So just do your math, watch your sig figs in units. So when you plug and chug this, you should hopefully get 0.142 moles. Okay, so for this problem, we had to do the molar mass calculation because it was a compound. All right, but the problems are pretty much all the same. You just have to remember for 1 mole, there's a certain number of grams using the molar mass or the mass from the periodic table if it's just an element. All right, so I want you to try this example on your own, pause the video, and then when you resume, the problem should be solved and you can see how you did. So pause the video and try it. So how did you do here? Hopefully you got this correct with the correct sig figs and units. And yes, because we were dealing with CO2, all right, it's a compound, you have to do your molar mass calculation. You have to show that there's 44 grams for every 1 mole. So these are problems using the 1 mole equals a certain number of grams molar mass conversion. One more example here that's a little bit more fun, but I want to walk you through this one together. You're more than welcome to pause and try it if you want. So for this problem, we want to know how many atoms are there in 12.21 grams of carbon. All right, so same setup here. We start with what we're given, 12.21 grams. Multiplication symbol, conversion line. Whatever unit we have on top, we immediately write it on the bottom, grams. Okay, so in this problem, I'm trying to get to atoms. So I ask myself, do I know a conversion from grams to atoms? And the answer is no. Okay, the only conversion I know here involving grams, I know that there's 1 mole for a certain number of grams. Okay, the other conversions involve 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, or formula units. Nothing with grams. Okay, so yes, I want to get to atoms, but I'm in grams and I can't go from grams to atoms directly. You cannot do that. Okay, you have to go by way of the mole first. So we know that for every 1 mole, okay, there's a certain number of grams here. Because this is just the element carbon, all right, you don't need to do a molar mass. You just look it up on the table. There's 12 grams of carbon for every 1 mole. Okay, so now that I'm in moles, all right, I'm still not in atoms, so you're going to put your multiplication symbol, put your conversion line, whatever unit's on top, you write on the bottom. So now moles is on the bottom. I'm still trying to get to atoms. So now I ask myself, do I know a conversion from moles to atoms? And now the answer is yes. I know that for every 1 mole, there's 6.02 times 1023 atoms here. Okay, so moles on top, moles on bottom, they cancel. Now I'm in atoms. So this just involved an extra step because you can't go directly from grams to atoms or from atoms to grams. Okay, so now you just need to do your math, watch your sig figs in this one. There's going to be 4 sig figs. So you got 6.125 times 10 to the 23rd atoms with correct sig figs and units. So make sure you can actually get this number and just be careful with that. You can't go directly from grams to atoms. You can only go from grams to moles. There's 1 mole for a certain number of grams. There's one more relationship, one more conversion here involving moles that we need to worry about. All right. So far we've been looking at, atoms, grams. That's great, except gases are very difficult to get the mass of. So we want to relate gases to volume in liters. All right. But the problem is with gases, temperature and pressure play a role here. All right. Depending on what the temperature and the pressure are, that could change the volume of a gas. So we have to assume that we're at STP for these problems. All right, STP stands for standard temperature and pressure, and those conditions are 0 degrees Celsius and 1 atm. That atm does not stand for atoms, it stands for atmospheres. It is a unit of pressure. Okay, so when we're doing these problems, as long as we're at STP, the conversion here that we know is that 1 mole of the gas is going to be equal to 22.4 liters. Okay, so if you're doing a problem here and they're asking about volume of a gas, we're talking about liters. And the problems might say you're at STP. Don't be afraid. That just is there because that means you can use this conversion. 1 mole equals 22.4 liters. If you have 1 mole of helium gas, you're going to have 22.4 liters of helium gas as long as you're at STP. Same thing for chlorine. If you had 1 mole of chlorine gas, you'd have 22.4 liters of chlorine gas as long as you were at STP. So again, it's just another conversion involving moles here that you need to know. Here's a problem that I completely solved just so you can see it, and then we'll work through some problems here together. But this says, what is the volume of 4.50 moles of CO2 at STP? Remember, that STP part is here just because that's telling you you're allowed to use that conversion that we know. So the problems are exactly the same as the other ones we've seen. You start with what you're given, all right? 4.50 moles, all right? Multiplication symbol, conversion line. Without even thinking, whatever unit's on top, you write on the bottom. All right, so you have moles on the bottom. So you say, okay, I need to get to volume, which is liters. So do I know a conversion from moles to liters? Yes. For every 1 mole, there's 22.4 liters. So your moles would cancel and you would be in liters. And when you do the math and watch your sig figs, you get 101 liters here. All right, so it's just another conversion that you're going to use in these problems and watch your units sig figs. Now we're going to try this example. It says, what is the volume of 8 grams of helium at STP? All right, so you immediately start with what you're given, 8.0 grams. Multiplication symbol, conversion line. Whatever unit's on top, you immediately write on the bottom grams. Okay, so we're trying to get to volume. Remember, volume is liters here. So we're trying to get to liters. So I'm in grams. So I ask myself, okay, do I know a conversion from grams to liters? And the answer is no. I know 1 mole equals 22.4 liters. Okay, do I know any conversions involving grams here? And it's yes, there's always 1 mole for a certain number of grams. Okay, so I know there's 1 mole for a certain number of grams here. This is just helium, so I don't need to do the molar mass. I can just look it up on the periodic table. There's going to be 4 grams for every 1 mole. Grams on top, grams on bottom, they cancel. So now I'm in moles. I want to get to liters. I'm not there yet. So my units, my friends here are telling me I'm not done. So I put my multiplication symbol. I put my conversion line. All right, whatever unit's on top, I immediately write it on the bottom. So that's moles. So now I ask myself, do I know a conversion from moles to liters? And the answer is yes. We know for every 1 mole, there's 22.4 liters. Moles on top, moles on bottom, they cancel. You're in liters, which is what you want. So now you just need to do the math here and watch your sig figs. We only want 2 sig figs in this one. Okay, so when you plug and chug, it should come out to be 45 liters. All right, that's correct sig figs unit. All right, so this one involved an extra step because you can't go directly from grams to liters. All right, you can't do that, just like you can't go directly from grams to atoms. Okay, so you have to go by way of the mole. I'm going to let you try this one on your own. So pause the video, try it, and then when you come back, you should see the answer and see how you did here. So pause the video and try it. This was a pretty basic problem here, just going liters directly to moles. So you basically know that there's, 1 mole for every 22.4 liters. Your liters cancel. Watch your sig figs, watch your units. We're going to do one more problem here, okay? And this one I'm going to walk you through. So it says, what is the volume of 8.80 grams of CH4 at STP? Remember that STP is there because that's saying that we can use that 1 mole equals 22.4 liter conversion. All right, so we start the problem the exact same way. We immediately write down whatever we're given, 8.80 grams, put your multiplication symbol, put your conversion line. Without even thinking, whatever unit's on top, you immediately write it on the bottom. So grams on the bottom here, okay? So we're trying to get to volume, which is, remember, liters. If it says volume, you're trying to get to liters. So do I know a conversion from grams directly to liters? No. I only know a conversion from grams to moles. I know for every 1 mole, there's a certain number of grams. Now, this is a compound. This is CH4. So you can't just look it up on the table. You have to do your molar mass, and you have to show it. So there's 1 carbon in CH4 times 12 is 12. There is 4 hydrogens times 1 each. So that's 4. All right, when we total this up, there's 16 grams per mole. Okay, so now we can use that here. There's 16 grams for every 1 mole. Grams on top, grams on bottom, they cancel. Now you're in moles. Your units are telling you you're not done. So you put your multiplication symbol, you put your conversion line. Moles are on top now, so you put moles on the bottom. So can I go from moles directly to liters now? Yes. I know for every 1 mole, there's 22.4 liters. Moles on top, moles on bottom, they cancel. You're in liters, which is what you want. So now you just need to plug and chug, watch your sig figs. So you should get 12.3 liters with correct sig figs and units. So this is just another conversion here involving moles, but we use moles and liters when we have gases at STP.